So a ball is dropped from 10 meters and bounces on the ground. At the top of each bounce, the ball reaches 40% of its previous height. So that's important information. Calculate the total distance traveled by the ball when it hits the ground for the 6th time. Total distance. So before I even begin this question, what I like to do is draw a figure of what I'm looking at. So the ball is initially at a height of 10 meters. So that's up here. Here's my 10 meters off the ground. The ball then drops down. So this will be the path of the ball. And I'm going to assume that it bounces up and down along a vertical line. So it keeps on going up and down, up and down, up and down, up and down until it stops bouncing. But instead of representing that all on one line, I'm going to represent the portion going up just a little bit over. So the ball comes down and then it goes up again to 40% of its previous height. So that would be over here. Okay, and 40% of 10 meters is just 4 meters. So the ball comes down, then goes up, and then it's going to come down again. And that path going down, I'm going to represent it by this. So this is the ball coming down, going up, coming down again. So the first bounce happens here. So that's bounce number 1. Bounce number 2, remember the ball comes down, then goes up, happens over here. Because when it goes up, then it comes down again. And that's my bounce number 2. Then it goes up again 40% of 4 meters, which is going to be, I don't care about the number, but let's say roughly around here. So it's going to go up, and then it's going to come back down, and that will be bounce number 3. So what I'm looking for is the total distance the ball has traveled when it hits the ground for the 6th time. So there's another bounce, it comes up here, then it comes down, that'll be bounce number 4, and then number 5 going up, coming down, and then number 6 going up and coming down. And I can't really represent those small distances, but I want you to get the picture. So you'll notice that for every bounce, there's 2 heights. Okay, we have the up height and the down height, except for the very first one, in which case it just comes down. It doesn't go back up to 10 meters. So what am I going to do here is, first of all, I want to figure out what kind of relationship this is. And I mean, we have looked at geometric sequences. 40% each time means geometrically, not geometrically, but what's happening is the distance is decreasing each time by 60% of the previous height, and that is a geometric sequence. And the way I represent that is each term, okay, or the height of the ball on the nth bounce will be the initial term 10 times 0.4, because it's 40% of the previous height, to the power of n minus 1. So a is 10 and r is 0.4. So what I'm looking for is the distance, the total distance traveled after 6 bounces. So what I'm going to do is I'm going to add up all those distances using my geometric series formula. So 0.4 to the exponent 6 minus 1 all over 0.4 minus 1. And if I do the math here, this will be 16.5984 meters. Now, that just represents one height, either the height going down or up, but it just represents one. So for example, it would consist of adding this plus this plus this plus this plus this plus this. What we're leaving out in each of these cases, except the first, is, well, what about the bounce up? We're not taking that into consideration. So what I have to do is multiply every single height by 2, or the total sum multiplied by 2. So I'm going to go S6 times 2, which is just this number here. Let me just copy it. Okay, that number there, and that's times 2, which gives us, let's see here, 33.7968 meters. Okay, now remember that includes twice the height, or every two, for every bounce we're counting the height twice, which means we're also counting the initial height twice, which we know is not included in the sum because there's only one initial height and it doesn't bounce up to that 10 meters again. So what we have to do is subtract from this 10, and that gives us our final answer, which I'll round to just 1 decimal place, 23.8 meters. And there's our total distance.